If your research or engineering projects are falling behind, EEprogrammer.com can help you get them back on track without exploding your budget. Let us know what you need. You'll find relief here. Visit EEprogrammer.com. We can help you.
What? Oh, I'm making gravitational waves. It's bloody amazing. They've been discovered 100 years after Einstein predicted them, although Einstein thought they'd be too small to see. See, the theory is this. He thought that space must be bendy. And if something's springy like that, when you hit it hard, you get a ripple travelling through it. Let me explain. What Einstein realised was that things moving in space, zero gravity, basically just keep going and going and going and going. So Einstein thought, why is it that some planets go in circles? And while he was having his breakfast, he realised that if space was curved, then that would make things go in a circle. But what could make space be so curvy? Because normally it's flat, right? So if you have something like this, a large mass, it will actually bend space, and that's what makes planets and moons go in orbits. There's no sort of magical attraction, it's simply rolling downhill. So Einstein said, space is not just square, it actually is a bit stretchy. So it might seem to you and me in everyday life that square things remain square, but if you put a heavy enough mass near them, if there was a black hole right here in this kitchen, then suddenly everything would get a bit warped. A black hole warps space in 3 dimensions as well. It's kind of hard to get your head around, but of course things tend to roll into it from this direction, that direction, also from that direction, and from underneath. This is the hardest thing to explain about space-time. Really weird. This has been proven since 1919, 5 years after Einstein put out his theory. The space is warped around the sun. In an eclipse, we saw light from a star behind the sun coming around the sun to us at the Earth. So the sun is literally bending space, and it does it to time as well. That's why scientists talk about space-time. So when things sit there by themselves, they don't really make gravitational waves. They warp space. It's not until something violent happens, like, they move around or suddenly land, but masses don't, like suns, don't just appear out of nowhere. Everything happens quite slowly, unless you get a collision. And that's what the scientists observed. A couple of black holes colliding. And that, as you can see, makes all of space quiver. Waves in space travel right to us where we can see them. So right here, a gravitational wave can come through and actually warp space. See, for a moment there I got taller and thinner, and then I got shorter and fatter, and then I went back to normal, and that was a gravitational wave passing through. But the really hard thing is, how are you going to measure it? Because if you have a ruler, as a gravitational wave passes through, it stretches as well. So you can't actually see it measuring. The only thing that you can use is light. It's a little bit like a black hole would warp space kind of like that. The only thing you can measure it with is light, and that's where LIGO comes in. They've used laser beams between 2 mirrors bouncing backwards and forwards. Got another set at right angles going backwards and forwards. And it's kind of a race between the light beams. They go out and back and out and back. When a gravitational wave comes through, one has to go a little bit further because space is stretched. The other has to go shorter, and suddenly one comes back before the other, and they can measure that distance between the 2 light rays. That's how they detected that a gravitational wave came through.